In this running example to demonstrate HydroVis, we are looking at the river system of Florida. Currently, the map visualization is showing the forecast for the amount of water flowing per unit time, that is stream flow. It also provides the option to visualize other forecasted variables of interest for the river system, like bucket, which represents the water level. We can zoom in and pan around in this map visualization to observe the data closely. Hovering over any river segment pops up a tooltip which provides concrete information about the forecasted variable of interest along with the geocoordinates of that segment. We can also click on any of the river segments in the map visualization to view more details about the forecast for that particular segment. These details are shown in the plots in the row at the bottom. The distribution plot in the bottom right corner shows the distribution of the outputs of the individual models in the ensemble for the selected river segment. We show both the forecast value in green, which is the raw model output, and the analysis value in blue, which is the refined estimate after performing data assimilation with the forecast values and the real-life observations. It helps us understand two things. First, how different are the distributions of the forecast and analysis values, or in other words, is the data assimilation process working as expected to refine the forecast values? And second, what is the nature of the distribution of the chosen forecasted variable? Gaussian, power law, bimodal, and so on. This can in turn guide the weather scientists in tweaking the forecasting model to better suit the distribution. Moving on, the first plot in the row at the bottom visualizes the changes over time in the forecasted variable, in this case, the stream flow. Plots visualizing changes over time are known as hydrographs in the hydrology forecasting community. Currently, it shows the forecasted stream flow averaged over the outputs of all the models in the ensemble. We also see the uncertainty or spread in the outputs of the model encoded in the width of the error bands. Specifically, the error bands represent the standard deviation in the outputs of the models in the ensemble. Note again that we show both the forecast value in green, which is the raw model output, and the analysis value in blue, which is the refined estimate after performing data assimilation, the forecast values, and the real-life observations. The legend in this plot also mentions observations, which are missing in the plot. That is because real-life observations are not easy to acquire at the required granularity, and therefore, not all the river segments have real-life observations. HydroVis allows us to toggle the observation gauge locations in the map visualization, and we can click on any of these gauge locations to view real-life observations at that location, along with the forecast and analysis values. The second plot in the bottom row, also another example of a hydrograph, shows the inflation value, that is the artificial spread applied to the forecast and analysis values and the changes therein over time. By enabling inspection of these artificial spread values, this plot helps weather scientists to triage the performance of the forecasting models and the data assimilation process. Taking a look at the interface controls now, HydroVis allows us to visualize the forecasted variable of interest, and for the chosen variable, we can also set different aggregation options. Mean value of the outputs of the models in the ensemble, standard deviation of those outputs, or even the outputs of individual models in the ensemble. These options update both the map visualization and the first hydrograph plot. The next set of options allows us to inspect the different phases of the data assimilation process. This includes both the forecast and the analysis values. This option only updates the map visualization. At times, the difference between the forecast and the analysis values may be too small to detect visually, as shown in the first hydrograph plot. The increment option allows us to visualize this difference exactly and helps us understand the data assimilation process is improving the forecasts. This option only updates the map visualization. The time slider can be used to inspect the forecasts for any timestamp of choice. It affects both the map visualization and the distribution plot. Finally, to enable information communication, HydroVis also allows downloading these visualizations to share them offline.